Question number 164. So replace the two forces. You have two forces, F1 and F2, and one couple. This is the couple. I call this M3. Acting on the rigid pipe frame. This is the rigid pipe frame. By their equivalent resultant force R. So we need to find the resultant force of these two. Acting at point O and a couple M0. So first we need to find the component of F1 and F2. First F1. F1 cosine 30 will be in these directions. Here I show the component of F1. So this is the angle of 30 degrees. So here F1 cosine 30 is the vertical one, and it is in the negative Z directions. Because of this I put negative K. So it will be F1 cosine 30. F1 is 200 cosine 30, and negative, because it is acting in this direction, negative Z. You see the direction here? K. What about this ones? It is directing it is parallel to the X direction, so it will be positive I. And how much is the magnitude? 200 sine 30. 200 sine. So this is F1. Let us get rid of the J component because we don't have. Now F2. F2 is parallel to the Y direction. Let me show you the real questions. If you see this one, this line is parallel to the Y axis. Okay, so it will be 240, but is it positive or negative? Negative, because this is pointing in the negative directions. So negative 240 times J. I will get rid of this 2. So R will be resultant force F1 plus F2. I just calculate this 2. So how much is it? 200 sine 30. It will be 100, and cosine 30 times 200. You just use the calculator. So make sure that at the beginning you just find the sine of 30. Now I understand that this is in the degree. 30 is degree, but some people put it in the radian and it will give them the wrong answer. Now I will put, okay, I will just do it again. So this is 30. I just type cosine 30 will be this, and times 200 times 200. You see, it will be 173.21. Okay, and negative 240J will be this one. So this is the R. Okay, it should be in the bold font. So now position vector. Okay, for R1, we need to find the coordinate of this point. Look at here, I start from O, I will go up. How much is this length? 300 millimeter. So it will be 300 times K, but it is in the SI unit. So we need to change 300 to 0.3 meter. So it will be 0.3 times K. And now we will go this way. How much is this length? 375 millimeter. So I will divide this number by 1000 because we want to see the answer in meter. So it will be 0.375 and it is directing this way, so it is negative. So this is the positive direction, but when we are moving from this point to here, it is in negative. And from this point to this point, this one is parallel to the y, but we are walking to the negative direction of y, so it will be negative. 250 millimeter we divide this one by 1000, so it will be 0.25 negative j. So R2, how much is the R2? It will be 0.3, but we have 300 millimeter, we will divide it by 1000, and we are going up, so it will be k, 0.3 k. So we will find the R1 cross F1 and then R2 cross F2. So you use the determinant ijk, you put in the first row, and then you will put the component of the R. So this is the first component of R, this is the second, and this is the third component of R. Remember, we always put R in the second row and F in the third row. Okay, so F1 will be how much? 200 sine 30, just copy that here, and negative 200 cosine 30, you will just copy this one here, and you can obtain this one as this. How? Remember, for I, you will just hold, you can do this, I will show you. In the exam, you will just use your hand, you will hide first column and the first row, and you obtain the determinant of this 2 by 2, which is negative 0.25 times this minus 0 times 0.3, which is 0. And for the second wire, remember that when you hide the second column, you have to put a negative, and then this one times this negative 200 cosine 30 minus 0.3 times this. And for the third row, you will do the same thing. You will just move this one here, and so we will obtain the determinant of this ones. And for M2, it is R2 cross F2. So what is R2? 0.3. We'll copy that 0.3. And F2 is 0, negative, and this one is negative 240. I will copy that, and I will obtain the M2 like before. And M3, so this is acting, you need to remember, instead of this moment, you will just use your right hand and you will find out the direction of this moment is this way. So this is parallel to the y-axis, but it is it is in the negative directions. So we put negative 48 j minus 48 j. Okay. So the moment about O is M1, which is this, and M2, which is this, and M3. We will just add the corresponding components. For example, the I for this one plus the I for this one, which is 72, and plus 0. You can obtain this easy.